Hello guys, welcome once more to class online, and my name is Tutu Dami. We shall be looking at Jamb Physics 2015 question number 6 to number 10 in this edition, and we shall be touching very difficult aspects of physics that many students find difficult in this series. Stick to us. Now don't forget that if you have any if you really enjoy this video or you learn quite some things from this video, to click on like button. We have loads of content that will better help you understand physics. Now let's get to question number 6 now. Longitudinal waves do not exhibit what? Now we have refraction, polarization, diffraction, and reflection. Now all waves, these are called wave properties. I mean, all the options A to D are wave properties, but there's one property that is not common to all waves, and that is what? Do you have any idea which one is correct? Now, first of all, we will begin by defining longitudinal wave, right? Now, longitudinal wave is the opposite of transverse wave. As you have it here, is the wave that travels in the same direction to its of propagation. That means it travels in the same direction of its propagation. While transverse will have waves that travel perpendicular to the direction of its propagation. That means it is moving. Transverse wave is moving like what you have there. Transverse wave, like what you have here, look at transverse wave. It's moving perpendicularly, up and down, up and down. That's the transverse wave. But longitudinal wave travels straight in the same direction of its propagation. But what is the property that longitudinal wave cannot do, like we have it here? It do not exhibit. Is it refraction, polarization, diffraction, reflection? The simple answer to that question is polarization, and I will tell you why. Longitudinal wave travels straight. Now, polarization is the ability to make wave to travel on a straight line. Okay, now that's to travel in one direction, right? Now, longitudinal wave are wave that travels in the same direction of propagation. Now, like example of that is what we call sound wave. So, but longitudinal wave can do all of them, but it can't do polarization. Only transverse wave can be polarized. What that means is that, transverse wave, example of transverse wave is light wave. Light is polarized. That means light can be polarized because light travels perpendicularly and directly. Like if you put on your torchlight, the ray of light can travel up, down, and forward because it is transverse. So transverse travels perpendicular to the direction of propagation. It can go up, down. This way light travels. So, and only transverse wave can be polarized. That means to be made to travel in one direction, in a straight line, and that's what we call polarization. But all longitudinal waves can't be polarized. Polarization is only for transverse wave, and that is the answer. So longitudinal wave can do what every other wave can do, like refraction, diffraction, reflection. It can do what every other wave can do, but it cannot be polarized, and that is the answer for that question. So they don't have to be made to travel on a straight line. They can be polarized. They can do others, but except polarization. Only transverse wave or light wave, which is also transverse wave, can be made to travel on a straight line by polarization, and that's the meaning of polarization, and that's the answer to that question. Now, number 7 says a device that converts sound energy into electrical energy is what? Is it the on of a motor car? When you press the on, it is electrical. It comes from electrical to sound, right? When you press the on in your car, it comes through electrical when you press into and produce sound energy. So the on of a car is electrical to sound. Then the telephone earpiece, the wave coming to you is electrical from your phone. Then it lands in your ear with sound. So it is also electrical to sound. Then loudspeaker is what? Loudspeaker is coming from the person speaking to you, but it lands in sound. It's passed through electrical and comes to you as sound. But microphone is coming from you, sound, into the mic, and it goes out as electrical, but it comes from your body, sound energy first to electrical. So the answer to that question is just microphone. It comes from your body, sound, to the microphone, and that is electrical. So it is from sound from you to electrical, and that's the answer to that question. Number 7 is therefore D. Number 8, a good calorimeter should be of what? Do you remember calorimeter? Calorimeter is a device used to show the transfer of heat or the distribution of heat within a system. Like if you are doing thermal physics, we talk about calorimeter when we talk about heat exchange between a solid material or a liquid material and water. Okay, so that's when you put a solid inside water, the heat distribution from the solid, from the hot solid to the water is read using a calorimeter. Is read or observed using a calorimeter. So calorimeter is used to observe heat distribution or heat loss from a hot body to a cold body. Now let's see what should be the property of a good calorimeter. Is it low heat capacity and low heat conductivity, or high heat capacity and low heat conductivity, or high specific heat capacity and low heat conductivity, or low specific heat capacity and high heat conductivity? Now this is a calorimeter. Now, and that's what I was talking about. It shows the distribution of heat within this system, and this stirrer is used to mix the heat so that the heat will circulate quickly. And this is the thermometer used to measure the temperature of the system, and that's a calorimeter for you. But generally, what should be the property of a good one? Now, I will just tell you the answer, and I will tell you why. Now, the answer is this: it has low specific heat capacity and low heat conductivity, and I will tell you the reason for that. The reason is because if the calorimeter, the word heat capacity means the amount of heat needed to raise the temperature of 1 kilogram of a body by 1 Kelvin. Now, the amount of heat needed to raise the temperature of that system, it must have low of it. It must have low specific heat capacity because of this reason. The reason is because it must not be difficult, okay, for the calorimeter to absorb heat, and that's because it must not have high specific heat capacity, because that means that it will need to absorb a lot of heat. The calorimeter must not be reducing the heat, because this calorimeter is a system that helps to watch the heat in the water. So if the calorimeter is taking part of the heat because it has high specific heat capacity, it is going to be making our answer on the water to become difficult or wrong. So the calorimeter must not be sharing the heat with the water, and that's why it should have low specific heat capacity. Then it must also have low heat conductivity, and that one is very obvious. The calorimeter must not be conducting out heat. If it is conducting the heat away, then it is going to reduce the heat of the system, and we will be getting wrong reading. So calorimeter must be off. Like you say, the hand of the calorimeter must be off the system. It must have low specific heat capacity and low conductivity, so that it will not absorb the heat of the system, and so that our heat reading will be correct. So a good calorimeter must not share the heat with the water or with the system. It must be off the system. It must just contain the heat and make the heat to become to be stable, and thus it must confine. It must confine the heat within the system and make none of the heat to be lost. Okay, and that's the reason why the answer is A, low specific heat capacity. It must not absorb heat and it must not send out heat, and that makes option A the correct answer: low heat conductivity and low specific heat capacity. And that's the answer for number A. Let's check out number 9 now. Which of the following is most commonly deflected by a magnetic field? Now this one is we have beta particle, we have gamma, and we have beta particle, we have X particle. What does that mean? We have gamma, particle, that's C, and we have X-ray. Now, which of them has is most strongly deflected by a magnetic field? Now, let me tell you something. For something to be deflected by a magnetic field, it must be very light. What that means is that for the magnetic field to be able to push you, that means you must not have weight. You must be very, very light and easy to push. Like if you say, which of the two of the following can be deflected by wind? Paper and stone. Stone is heavier, so the wind can't deflect stone. But paper can be lifted by wind. because it's light, right? Now, which of them is the lightest that a magnetic field, the magnetic field can easily push or deflect? Is it beta, X particle, which means nothing, then gamma and X-ray? Now, the simple answer to that question is simply beta. Is beta particle. Look at it. We have alpha particle is what? It is heavy. It is heavy, positively charged particle. They are deflated slightly in one direction. Now, alpha 2 can be deflated but slightly. And this is because alpha particle is made up of proton and neutron, and those are heavy particles. They are heavy atomic particles. So, but beta is negative. It is light because it is negatively charged and it has electron. And now, electron has no mass. Electrons are actually very light. They are not heavy at all. The mass of an atom is in the nucleus of the atom, where the proton and the neutron are. So, but the electron move around. An electron is extremely light. It is in science, we have seen that the mass of an electron is 1/1840, and that is the mass. But that means it is extremely light. So the reason why beta particle will be deflated is because it is made up of electrons, and electrons are very light. So beta will be deflated because beta is very light, but alpha is heavy. Why gamma is not? Gamma is extremely heavy. It can't be deflected. Actually, gamma can't be affected by magnetic or electric field. Gamma is on its own. It is on its own. So it can't even be sensed by magnetic or electric field. It can't be sensed. So it is unaffected by them. But alpha can be deflected a little. But the one that will be strongly deflected because it is extremely light is beta particle. And that is because beta is made up of light particles called electrons. And that's the answer for number 9. Beta particles. Let's check number 10. If a beaker is filled with water, it is observed that the surface of the water is not horizontal as the glass water interface. This behavior is what? Now, if you put water in a beaker and then you look at it from the side, you will see this happening. You will see that the water is not straight. Looking at water by side, the meniscus of the water will be bent. It's not straight. It's not like it's not straight line. No, it will curve. Not curve outward. It won't curve outward. It won't curve outward. It will rather curve inward. That means it's not straight. It's not horizontal at the glass body. Now, why is it so? You can see this is also part of what we are talking about. It is not straight. It is not horizontal. If you are looking at it from the side, water will form a curved meniscus. Why is that so? Why is it not straight meniscus? The reason is because of a phenomenon called what? Do you think it is friction, surface tension, viscosity, or evaporation? The answer, you are correct, is surface tension. Why is that so? Because there's a tension between, there's this attraction force between water and glass, and that is called an adhesion force. So it has greater adhesion than cohesion. That means I can say it like this: water loves glass, so therefore water stick or water always embrace glass. So if you pour water on glass, it will splash. But if you pour mercury on glass, mercury will just form bulb. Mercury has stronger cohesion. That means attraction for itself. Mercury does not embrace glass. So mercury does not open up to glass. It only forms a bulb and say, glass, I hate you. So it will form bulb. And that is stronger cohesion. That means it has stronger attraction for itself than for glass. So it has stronger cohesion than adhesion. But water has stronger adhesion. That's affinity for glass than cohesion for itself. So it splash glass. And that's why water will form this concave meniscus with glass. It will form a concave meniscus. And that phenomenon is interpreted as surface tension. It is due to surface tension between water and glass. And that is the reason why it is not straight. Surface tension makes the surface of water to open up. It will open up. It will open up. That means it will behave like it is covered by a thin surface, right? And that's the reason why water forms that meniscus. And that brings us to the end of this video. Don't forget, if you learned something from this series, click on like button. We have other content that will better help you understand physics as you go. Until we see next time, guys, take care of yourself and bye for now.